quiz. We're going to work through one together, and then you need to finish the back side correctly in order to retake the quiz. So here we go. We are starting at the battery, the negative side. We are going to take our first set of current. The red line leaves, it goes through resistor 1. At this point, it can split. It can either go up the inside path and back through resistor 4, or when it gets to this point, it can go up the outside path and back around. We have to figure out what are series resistors, which means they get all the current, and what is parallel, which means the current splits. So it only gets partial current. Okay, so if we look at our 4 resistors, resistor 1, 2, 3, and 4, we have 2 resistors that get all the current, both colors, and we have 2 resistors that only get some of the current, one color. So as we look, resistor 1, all the current flows through it, both blue and red. That makes it series, so I'm going to circle it. Resistor 2 only gets red, parallel. Resistor 3, only blue, parallel. And then eventually all the current comes back together and all of it flows through resistor 4. That makes that series. So when we're going to solve for the total resistance, we have to do the parallel ones first. Anything that does not get all the current goes 1 divided by. So we start by finding the parallel guys, which is 200 and 800. So we go 1 over 200 plus 1 over 800. You type that into your calculator. 1 divided by 200 plus 1 divided by 800. You get a very small decimal. It was like 0.00625. That is not the resistance for those two. That is 1 divided by the resistance. So we go 1 divided by second answer, and we get a total of 160 for the 2 parallel resistors. We then have to factor in the series resistors. They just add normally. So to that 160, we add 500 and 200 to get our total resistance for the whole circuit to be 860. Once we have that, our next step is always, always, always to use Ohm's law. We take the voltage of the battery, 100, we set it equal to the total current multiplied by the total resistance. If we divide that under 100 by 860, we are going to round to 3 decimals because the last one is kind of in the middle. So it's going to be 0.116 amps is our total. At this point, I'm going to take a moment and I am going to get a list under each resistor of the I, the current, and the voltage. It gives me a spot to put everything and to help myself keep organized along the way. Okay, the only place you can start is with the series resistors. Series resistors got all the current, both colors. All the current is 0.116. So automatically I1 is 0.116 and I4 is 0.116. This got all the current, this got all the current. All the current is 0.116. So I1, 0.116, I4, 0.116. I am now going to multiply. I am just using the only equation I can use this entire time, delta V so I times R. For resistor 1, I have R. I multiply those to get me the voltage. If I take, to find voltage 1, if I take 0.116 and multiply it by 200, I get a voltage of 23.2. If I repeat the same thing for resistor 4, I take I times R, I, so delta V4 is I, 0.116, multiplied by the R of 500. If I multiply those together, I get 58. All right, I have have done my 2 series resistors. I gave them all the current and I then multiplied to find the voltage. To make the jump to the parallel guys, I have to jump through voltage. When you follow a loop, all the voltages have to add up to the total of the battery. The total of the battery is 100. If I follow the inside red loop, I go through resistor 1, resistor 2, and resistor 4. This voltage plus this voltage plus this voltage has to add up to 100. So delta V1 plus delta V2 plus delta V4 has to add up to the total, which is 100. I already know delta V1, 23.2. I don't know this one yet. That's what I'm solving for. But I do know that one is 58. If those 3 things added together after equal 100, and I have those 2 numbers, I need to subtract away. The remainder is going to be the voltage number 2, and that is 18.8. Automatically, I can also put 18.8 right here. All parallel resistors get the same voltage. The reason for it is if I now follow the blue path, I go through resistor 1, 3, and 4, not 2. So if I follow the blue path, all I'm swapping out is that voltage in place of that. It goes through resistor 3 instead of resistor 2. Still goes through 1 and 4. Those 2 numbers are still the same. I still subtract. I still get 18.8. So automatically, those voltages are going to be the same number. And my last process to find the currents, I once again use that equation. I now have the voltage and I have the resistance. I'm going to divide to find the current. So if I do the inside loop, the red loop, I'm going to take 18.8, set it equal to I2 multiplied by the resistance. I'm going to divide 18.8 by 200, and I'm going to get I2 to be 0.094. If I repeat that process for resistor 3, delta V equals I times R, 18.8 equals I3, multiplied by 800 is that resistance. When I divide the 18.8 by 800, I get 0.0235. All right, so we have worked through the front side of the retake assignment. Your job then over the weekend is to work your way through the back side, and that will give you your ticket in to retake the circuit quiz. Thank you.